All right, so this is lab one for physics two, calculation of transferred electrons. So the purpose of this lab is to understand how charging works and the effects of charge imbalance. The results of this lab were that the tape becomes positively charged. The electrons transferred was 3.125 times 10 to the 10th, and the eventual ratio of electrons to atoms left was 8.2 times 10 to the negative eighth. Some quick assumptions. We're assuming that gravity equals 9.81 meters per second. The charge of both tapes are equal. The density of each tape is 1 gram per meter. The electron charge is exactly 1.6 times 10 to the negative 19th coulombs. Each U-tape is being considered as a point charge, and no grounding has occurred. We're going to be using Newton's second law, F equals ma, as well as the concepts of the electric field and the electric force and how we calculate between those two distinct ideas. Some more experiment parameters. Each U-tape was made the same. They were peeled off quickly from another piece of tape to charge. The system was tape B with a length of 20 centimeters and a width of 0.019 meters. The surroundings of tape B were gravity and tape A, and each of these things were measured with a basic physical means and observations. First, we had to determine the charge direction. Pen is a known net negative, and tape was attracted. Therefore, it is positively charged. To calculate the number of transferred electrons, we started from Newton's second law, where we had a positive force of electricity minus the force of gravity equal to 0 because the tape did not move. Working it out, we got a charge of 5e to the negative 9 coulombs. And calculating out the number of electrons that would be is just dividing that by the electron, uh, the amount of charge each electron has, coming out to 3.125 times 10 to the 10th. Measuring it against our computational model, it is practically the exact same. The charge is simply a little bit more exact, but is still about 5 times 10 to the negative 9. To calculate the ratio of transferred electrons, we have to make a couple more assumptions. We assume that density is uniform and that the electrons are transferred uniformly. If there are pockets of greater positive charge, the interaction between the two tapes will be a little bit different. To calculate the atoms and the number of atoms in the tape, we have to go through and multiply the length times the width, coming out to 3.8 times 10 to the 17th atoms in a piece of tape, in our piece of tape. And the ratio of these transferred electrons, these lost electrons, divided by the number of atoms left, ended up being 8.2 times 10 to the negative eighth. So there were some potential sources of error. Our initial assumptions could be wrong here. Our last sig figs were guessed wrong. We were using rulers to measure the distance between tape A and tape B. And while we were able to get close, that last sig fig might be incorrect and could cause a lot of error if it is wrong. Thirdly, additional initial assumption, the pen might actually be positively charged, and so the direction might be in reverse. So some quick final observations. What if electrons have positive charge and protons have negative charge? Probably nothing different, besides the uh, nuclear structure being a little bit different. They would act relatively similarly. Um, it's important to handle the ends of the tape to prevent grounding, in which case the charge will rebalance into an actual neutral object through the transfer of electrons from your hands into the tape. Thank you.